Welcome back to STEM Mondays. I'm Bradley Rivera, STEM coordinator and co-host. And today, for episode 2, we're going to be performing 2 experiments all about the topic of density. Let's go to the lab.
Welcome to the lab.
Today we are going to be making a lava lamp.
Lava lamp? I haven't seen one of those in years.
Gaddiel, don't lava lamps use heat from light bulbs?
Well, yes, but we're not going to be using it today. We're going to be observing the concept of density taking place.
Wow, that sounds interesting. What materials do we need?
Okay, this is simple as we need a flask. Okay, if you're going to do this at home, please try to do something that is use something that is clear so you can see what is going on. We're going to be using vegetable oil. We're going to be putting a little bit of food coloring, some marbles, and we're going to be using Alka-Seltzer.
Okay, let's get started.
Yeah, let's do this.
All right, so first let's measure out the vegetable oil.
How much do we need for that?
Today I'm going to be using 600 milliliters of vegetable oil. But at home, you just need to have 3 times the amount of vegetable oil as you do water.
So for example, if you need 1 cup of water, or if you're going to use 1 cup of water, then you're going to use 3 cups of oil.
Awesome.
What is the next thing when you put in the flask?
The next thing we're going to put in the flask is the water.
Yeah, let's do this.
Look at that.
Starts getting, interesting.
I wonder what's happening.
What's next?
Next, Gaddiel, we have 20 drops of food coloring.
Okay, I want to do that.
Okay.
Let's count them.
Next, we're going to use a colored marble. Just drop it in your container. Whoa. All the way at the bottom. Okay, guys. We're going to be dropping the Alka-Seltzer tablet inside of our Erlenmeyer flask. What do you think is going to happen?
I don't know, but I just really want to see how it goes.
Oh, okay. Do you see the bubbles?
Yes. Okay, people, was our first experiment for today, but we have another one. Again, trying to see how density is taking place.
Now we are going to be performing our second experiment of the day. What are we going to be doing?
Well, Molly, we're going to be doing a color stack.
What materials do we need for that?
It's a simple list. We just need water, sugar, and food coloring. So,
Sounds easy enough.
yeah, it's really easy. We just need to be careful how we stack the colors. So, what is a color stack? We're just gonna do a column of colors, and using the factor of density, we're gonna be able to divide the colors evenly, and you're gonna be able to see the colors similar to when we see a rainbow.
Sounds awesome. Let's get started.
Okay, I'm just gonna explain you more or less what you need to do to be able to divide the colors in different layers. We're gonna divide, or more or less have the same amount of water in different cups. We're gonna use 5 cups, and the only difference is gonna be the amount of sugar, okay? Because that is gonna make each of the liquids that we have here have a different density, and that's what we're gonna use to divide the stack in different layers. And we're just gonna use food coloring to identify the different layers depending on density. So let's do it really fast. We're gonna divide. We have divided already the different cups that we're gonna use. Base
Amount of sugar?
amount of sugar we're gonna use. The first one is not that we have is just gonna be water. The second one is gonna be, we're gonna include 2 spoons of sugar, and from that point on, we're gonna add 1 more spoon of sugar to the next cups, meaning that the second one has 2, 3, 4, and 5 spoons of sugar. So we already pre-dissolved the sugar in a couple of these cups. We're just gonna show you what you need to do.
Wait, I have a question. How many spoons of sugar are in that one?
If we started with 2, 3, 4, and 5.
Okay, so our first one has no sugar.
No sugar.
Okay.
It's just water. The only thing is that we just warm the water a little bit to make the sugar dissolve easier in the water.
Got it.
So I'm gonna use the cylinder to pour the water. I'm just going to mix it up. Okay, I think it's more or less good. And now we just need to pour in the food coloring to be able to differentiate the different layers. You want to help me out?
Of course, I'd love to.
One, 2.
Wow.
Again, we just want to mix them up. There's an important thing that you need to take into consideration. When you are going to start putting the water on the stack, is that you need to do it carefully. Okay? You don't want to do it like too fast, because if not, you're going to mix up. For that, we're going to use dropper. Let's see.
So we're gonna start with
The more dense.
more dense. Okay.
And we want to put up more or less, in this case, we're going to be using about 20 milliliters for each layer.
20 milliliters for each layer.
Now we're going to finish with our last color, that is just water.
Wow, so starting from the bottom, you have red, which has, I forget, the most density or the least?
The most dense.
The most density red. And then green, and then purple, yellow, and blue.
And remember people, we did this just changing the density of the liquid, just adding more solid, adding more sugar to each of the cups. And that way we're increasing the density, and that is going to make this possible. Having different densities that we're able to identify with different colors.
Awesome job, Gaddiel.
Thank you. So people, that's it for today. See you.
Bye.
Okay, so I have here the results of our first experiment, and you might have noticed that as Molly dropped the marble inside the lava lamp, it went straight to the bottom, right? So that happens because the density of the marble is actually much higher than the density of the vegetable oil, the density of the water. So it's gonna go straight to the bottom. Now, let's study the relationship, the mathematical representation of density using the second experiment. So we have that the mathematical relationship is the following. Density equals mass divided by volume. Mass over volume, right? So for our experiment, we were keeping the volume constant. We had a volume of 60 milliliters. So if we go back to our formula here for density, we have that the density in our experiment is going to be the mass over 60, which is the volume, right? Now, here's the trick. As I add more sugar to the mix, what I'm doing is actually increasing the mass. And as I increase the mass, I'm going to be increasing the density at the same time. So this is how it's gonna look. Let's say that this is the density of the first glass of water. Now, suppose that we have another one. We're gonna calculate the density of the second glass. Now, I'm gonna add sugar such that I double the mass of the water inside the glass. And now we have that the second density is gonna be 2 times the mass over the same volume of water, which we're keeping constant. So this is gonna be 60. Now, you might have noticed that these two they look similar, but they're not the same, right? This one is 1 times the mass, this one is 2 times the mass. And immediately I can notice that there is a common factor here between 2 and 60. And I can simplify that such that I get that the second density is now going to be the mass over 30 by simplifying 2 and 60, dividing by the common factor, which is 2. Now, if we compare density 1 with density 2, you're going to notice that you're dividing the same mass by a bigger denominator or a bigger number here. You're dividing it by 60. So this is going to give you a much smaller number. Once you find the quotient of these two values, you're going to get a lower density. Now, as I divide by a smaller number, what I'm going to get is a higher density. And this explains why we can keep different layers stacked on the same tube of water. Thank you for watching episode 2 of STEM Mondays. Our challenge for this episode is for you to replicate at least one of the 2 experiments that were showcased. Take pictures, video, send them to us so that we can share your results with the community. We also want to give a big shout out to Anna Sgroy and Michael Sgroy for completing the Elephants to Space experiment. If you want to see their results, check out our Twitter and Instagram pages and stay tuned for the next video that's going to air on YouTube and Facebook. Stay tuned.